So yesterday you had the example, because we could not use the calculators, and we said use log base 2 of 3, that is approximately 1.5850, to approximate the value of log base 2 of 48. So we tried to get 48 so we could get log base 2 of 3 out of it. So we said 48 was the same thing, I don't know, you guys gave me different products for 48, but we said if we can get to 6 times 8, 6 was the same thing as 3. So 3 was a factor, and we could say log base 2 of 2 to the 4th times 3. And then we said the concept that we learned yesterday was that if you multiply, if you have factors for the argument, it's the same thing as taking the sum of the two logs. So we took the sum of the logs of the two separate factors, and we knew that this first one, we knew that this first one had a value of 1.5850. What does log mean again? That was your bell ringer yesterday. Exponents. So 2 to what power is 2 to the 4th, knowing that log is asking for the exponent, that had a value of 4. You add them together, and we can come up with the approximation. So going back to your bell ring, what could we do for the very first one? We could factor 18. What factor are we looking for when we're trying to put it into a factor form? A 2, because that's what I know the log of. So if I factor it with a 2, since my pen's still in there, you have log base 3 of, the factors would be 2 and, we could put 3 to the 2nd, which is 9, right? What do we do with the, when you are multiplying here, what does that tell you? You can add the logs. So what would it turn into then? Log base 3 of 2. Log base 3 of 3 to the 2nd. What operation do we perform between them? Addition. Because exponents, the rule for exponents, if you multiply like bases, you add the exponents. So we're adding the exponents here because we're multiplying bases together. What does the first one have a value of? 0.6309. And the second one has a value of 2. So the overall value or approximation of log base 3 of 18 is 2.6309. All right, now I want you to try the second one on your own after we had that refresher from yesterday. As I said, this was just a little bit of a challenge. And if it deals with exponents, we said, of course, if we're multiplying bases together, we're going to add the exponents together. And this log is an exponent. This is an exponent, so we add them together. What happens when you divide exponents? You subtract them. That's what leads us into another property of logs that we're going to get into today. So as we work through this one, how do you think I could write that? Log base 3 of 7. You want to think that it's over log base 3 of 2. But remember, we're talking about exponents. And what do you do with exponents? You subtract them. So I'm going to subtract log base 3 of 2. We would move this 2 up. Think of it this way. You take log base 3, we're talking exponents, 7 over 2. Maybe I shouldn't do that. I was going to say you move it up and you make it a negative exponent. But I better not do that. I might change it just a little bit for you. We'll leave this right here. All right, what's log base 3 of 7? 1.7712. And I subtract from it. We know the value of log base 3 of 2. That is 0.6309. So if you subtract them, what do we get?
We get 1.143.
1 4 what? Oh, 3. 0 3. There you go. Keep that. I'll just have you add your progress onto it. to turn in, okay? I see you guys were struggling with from what we did yesterday. Yeah. All right, so. They should. If they're asking you to approximate it, they will give you an approximation up at the top within the problem. Just keep it for right now. I'll have you turn it in with your year progress. This one is a year progress. It's definitely going to be turned in. So go ahead and work through this one. Aaron, how did you factor it? 2 times 4 to the second. Because the base is here, you want one of them to be your base. Because you know what the answer to that is. It's your exponent. This part right here, log base 4 of 2, we know the approximation of. Some of you had 2, and it's like 2 to the third because you broke one of the 4s down again. But I don't know about 2 to the third here. So yes, you're on the right track, Aaron. Now finish it. Aaron's got you. So we know we're going to add, and you're going to come up with your answer. I just want to see your progress on that. Oops. Don't have something inserted. Can I insert it real quick? Thought I had it inserted and I don't. You might want to converse with somebody, make sure you have the correct value. All right, here we go. So this new material here. What was the answer? Well, I don't know. I want to see your work. I want to see your progress on it. Can't you go from there? You worked through it correctly. What's the first one? Log base 4 of 2. What's the times? Plus. Log base 4 of 4 squared. What does this have a value of? 0.5. That's given to us from the given information, correct? So that has a value of 0.5. What does this have a value of? 2. So what is your answer? 2.5. Add them together. Which leads us into the new material, which was your third bell ringer that I had up there, seeing if you could remember what I mentioned yesterday talking about exponents. Since logs are exponents, if you were dividing, if you divide, say if I had x to the 5th divided by x to the 2nd, what do you do to the exponents? Subtract them. You subtract by moving it up, and then we say that our answer is x to the 3rd. So what we're going to do is work with logarithmic format now instead of exponential format, but you're dealing with the exponents. So the logarithm of a quotient is the difference of the logarithms of the numerator and the denominator. For all positive numbers m, n, and b, where b does not equal 1. Why doesn't b equal 1 again? We talked about that one yesterday too. You get a straight line, right? Because 1 to any power is 1. So it doesn't hold to the exponential part. So if you divide, if your argument is division or a fraction, you subtract the log of the numerator and the denominator from each other. Subtract the numerator from the denominator, the exponents, you're going to subtract them. So an example, if I gave you this right here, we want to take this argument of 4 and somehow get 4 out of the values that I know. what can I do with those two given logs to come up with log 3 of 4?
Yeah, so 20 divided by 5 is
20 divided by 5 is 4. So we can rewrite this as log base 3. Instead of saying 4, let's write it as 20 divided by 5. That is still 4, right? Now we're looking at exponents. You know each one of those values. What do you do to them?
You guys subtract the 21.
You subtract them. So it's the log of the numerator minus the log of the denominator. What is log base 3 of 20? Minus, what's log base 3 of 5? Uh-oh. Oh my goodness gracious. I'll tell you what that approximation value is. I think. Maybe. Maybe. Log base 3 of 5 is 1.4, 1.4650. So what's your overall answer? I'm going the other way. Sorry to let you have a calculator, but I know what you're going to do on it right now. You're just going to type it in. Get your approximation. Pull your calculator out. Type in log base 3 of 4 and tell me if it's equal to approximately 1.2618 to prove that this method works. Type in log base 3 of 4 and tell me what you get for a value. 1.26185, whatever. And we can get to that by taking approximations. How do you type in log? How do you find them? Alpha window.
Shut up.
I will have to look at yours. I have no clue on yours. If you have the graphing calculator, how do you get the log? Alpha window 5. Alpha window 5, and then it'll put it right in the format for you.
Oh, that's what you meant by doing that.
You have to hit the window. Clear it. Clear the whole thing. Now hit alpha window. Number 5 is log, right? Now arrow to your base. What's your base? 3. What's the argument? What's your argument? 4. And you get this. Alright, put your calculators up. And we're going to look at another example. What about this one? Use log base 5 of 2 and approximate the value of log base 5 of 250. Now you got to be a little creative. How can I get 250 using just 2 and base 5 powers?
2 and 125.
2 and 125. You're correct. How would I use that? How would I write it if that's correct?
124.
Log base 5 of 2, and what do you do with 125?
Plus.
Oh, plus what then?
Log base 5
Of 125, because we know that if we are adding, now we're going just a little bit the different way, Jackson. If I have this, I know I could convert that back to this format. I could convert it back to that format right there. 2 times 125 is 250.
Yeah.
You went directly to here. So you could go either way with this, just like we can go exponentials into logarithmic format or logarithmic back into exponential format. You can do the same thing with the properties of logs. Now what's this have a value of? 0.4307. 5 to what power is 125? 5 to the third. So your answer is 3.4307. What about this one? This should be, this is what we're trying to find. You're working with 32 and 8. 32. So if I take log base 6 of, what did you say, Anna? 32 over 8. 32 divided by 8 is 4. We are subtract, or, oh, I just told you. You are dividing, so what do you do to it? Subtract. So you're going to take log base 6 of 32 minus log base 6 of 8. You're just talking about exponents. What's the value here? 9343 minus 1.6. Take your calculator, subtract the 2 if you really want, since some of you were having a hard time for subtraction. Then type in log base 6 of 4 and see if it's the same thing as you get when you subtract these two from each other. You should get the same value. And the value you get is 0.7737. Back in the day, before they could develop these fancy scientific calculators, you had to do this process and you had to use a table of logs. And you had to follow across on this table and find out what the approximate value was, and you had to use these properties because all you really were working with is exponents. So knowing the properties can help you simplify some problems. Your progress, go.
You're going to subtract, like you're wanting to get log 5. Yes, 5, and then 1 is 5, 5, 1 is 5, 7. So 7, you're going to take 0.8917 minus 1.2.
Because you're looking at exponents, right?
Yeah.
You're looking at exponents, and as you go through, when you divide bases, same base. What base are we in? What's the base? She missed it right there. The base is 5. If I ask you the log base 5 of 21 divided by the log base 5 of 7, you're going to get some value here and you don't know what it is.
Yeah.
And you're going to get a value here and you don't know what it is, but those two values are what? These two values are saying this, 5 to what power? This is saying 5 to what power? But it's got to be a different power because I have a different answer or argument. When you have two bases that are the same, what do you do with the exponents? You are probably used to that. You're going to bring this up and make it 5 to the negative y, but what are you doing to the exponents? Subtracting them. And what is your answer to a log problem? An exponent. Any of them, because you're just looking for the exponent. Here's an example. Here's application of it, okay? Application of it. The loudness L of a sound measured. We did this one, right? We've worked with this one. What did we work with it as? Fireworks. We worked it as fireworks for one of them. The loudness L of a sound is measured in decibels is given by L is equal to 10 log base 10 R, where R is the sound's relative intensity. Suppose one person talks with a relative intensity of 10 to the 6 or 60 decibels. Would the sound of 10 people each talking at the same intensity be 10 times as loud or 600 decibels? And explain.
Wait, how is 10 to the 6 or 60?
Because they're just talking about the relative intensity of them. So there's different ways we could represent that, because we're going to talk about it as, I will show you why here in just 1 second. Okay? So as we look at it, we can change it into a log problem. We have the loudness or the relative intensity is 10 log base 10. And then what is R? The relative intensity. What is the relative intensity of a person? 10 to the 6th. Let's look at it as that. How can I go from there to see if that is either 10 times as loud or 600 decibels. I'm going to give you a minute to discuss amongst yourself how you think you would go from there. Anybody have anything to add to this? How many, what are we trying to compare? Are we only talking about one thing like we did the fireworks? We're talking about 10 people versus what? One person. So we actually have two loudness or, we're talking about two different loudnesses that we want to talk about, right? Compare. What is this right here? Just one person. What do you think you would do if you had 10 people talking? What do you think would happen to the loudness? Okay, just have one person talk. Keep talking just a little bit. Random talking. All right, now talk 10 people talk. What happens to the loudness in here? All right, do you think that loudness was 10 times as loud? Or was it 600 decibels? We have two different loudnesses we're talking about. Loudness 2. All right, I'll let this one be the one. Loudness 2. What's loudness 2? They want to know, is that loudness going to be decibels? What's decibels represent? That's your R, right? Your decibels is your R. I want 10 times as much. So if I take that 10 times one person, which is 10 to the 6th, where do you think you would go with that? I want to compare them. How many times greater is that? Is that so many times? Is that 10 times as loud? Or is that 600 decibels as loud? Let's work with it. I want to find the difference, right? What's the difference between the two of them? So I want to take loudness 2 and I want to subtract loudness 1 from it. What's loudness 2? How do I represent loudness 2? 10 log times, what's understood to be there if I don't put that there? 10. I can put it there though, but that's what's times 10 to the 6th. But I want to subtract from that 10 log base 10 of 10 to the 6th. I have something in particular right here. What have we talked about? How can I write that? Abby, do what? 10 log 10 of 10 plus the same thing except for the argument is 10 to the 6th. And then I am subtracting. Whoops, that's a nice log right there. What happens? Those cancel. So your answer is log 10 of 10 and a 10 in front. Oh, wait. What's this have a value of? 1. So it is 10 times 1, which is 10. It's only 10 decibels louder. What is the loudness of one person? What did we say it was up above? Yeah. So then it's just going to be 10 more than that. And that's it. Keep that in mind because your bell ringer tomorrow might involve. Oh, so sorry.
Where do you want that?
You start trying to steal
I think there's a whole bunch of this in there.
And then in your progress, I don't know.
Mine doesn't have scribbling.
Really? Right there.
Yeah, I might be surprised, but just a lot of random numbers.
Maybe.
Except for the first meeting.
Good. Milo, what do you got to work on today? I didn't get to remind me to come back to this tomorrow because the reason that this is 60 is it's because you have what's the answer to this part right here? Your exponent is 6, and you take it times this 10, which makes it 60.